Hello there. Just a very quick addendum to the last one. It didn't take very long, really. Um, my first guess was right. It's pretty obvious, I suppose. Defined this call for the math object. Oh, and I renamed a few things, or gave meaningful names to some things, like IID math is and so on. In particular, my interface called iMath, and a pointer to that is a pointer to an iMath. And this call, math, is a standard call that returns H result, taking a pointer to math interface and a pointer to long. Okay, so if it's reverse pushing, the interface pointer gets pushed last. And then with the addition of one more of these types of functions, get nth function address, which it won't find for some reason, but it's the same file. Get nth function address for I unknown function number. First I test to see if it is zero based, so if the number of functions exposed, if there were one, then 0 is the only valid number. So it's just 1, if there are 2, then it's 0 and 1, and so on. So I just take the address of the dispatch table for that thing and return the u function numbers element. Okay. Now, through macro, call and report is a macro which takes a descriptive operation word for the printout, and that's the same as before. It goes in the printout. The dots are a variable argument list for a macro. Means that anything that follows is represented by this symbol. So the return value equals whatever follows that OP. Oops. So now, I could write it out explicitly, but this will HR will be equal to this, right? And this is just for display. I could put that OP in here, but it won't. It's clearer this way, I think. So here's one way of doing it. This is using the arrow operator. And another way of doing it is through these function calls, which I've taken out of the dynamic dispatch table. Define them here. This is a function called math square root. That is the third function of pmath, and square is the fourth, and cube is the fifth. And I'm just assigning them and calling them here. The first argument is this pointer. Second argument is the argument. This all compiles fine. I can run it up to here. I'll put in a number, 1, 2, 3. Now it's printed out the addresses of those three functions. But first, we'll go through this method. So it's just doing this exactly, right? According to the macro. VAR is that. If you don't believe me, I'll do it again. So this gives, as before, whatever, square root's 11, square is that, and the cube is that. Draw a line, and now here I'm using this method, different method. I'll just step over them. Well, I'll step into one. Takes us here. The important bit to note is that this here is reasonable. It's not that this accumulator thing is always coming up. I could do it in reverse order, I suppose. The value 11, right, is computed, returns SOK, and that's printed out as 11. And similarly for the other two, get the same result. This is not using any arrow operator, no operators being used in these calls. Now, if you want to see it, just take one example like square root. Item equals, what is it, value? Pmath square root address item. That's one way of doing it. I'll just go through it for the debugger. Now I got to refresh this again. And now I'll use the other method. Pmath is our object. Address item. And both should give the same result. Right? The only thing that'll be different is the accumulator bit. So I can do it in reverse order. But we'll know after this first one that it'll be, depending what I type in, we know what it should be the next time we see it. I'll do a big number, 5548. Okay, let's step in here. Okay, we're going to take the square root of that. 74. So accumulator is 74. And the answer is printed, 74. I'm going to refresh this temp back to the original value. Now this here is just a function call, right? It's this type of call. Does this help? What does it do to call? Well, it's call and it's in a variable, so you can't see the actual address. I'll just F8. Okay, now the accumulator is correct, 74. So we know that we got this pointer in. We take the square root, another 74. That turns okay. And we print it out, 74 again. Okay. I forgot carriage returns there. So now you've seen it. either way you want to do it. We can call these functions using the arrow operator, or we can call them directly knowing the format of the call, standard call, and the first argument, meaning last thing pushed, is the interface pointer. In fact, it could even be the internal pointer as well. That would get converted. But anyway, the interface pointer, and then the argument, just as you would in regular C if you wanted to call a function and supply a type of pointer to struct. You would pass that as an argument. Same thing here. So there you go. If I only did this, we're now doing COM without the arrows, except for this release. I would just need another type def if I wanted to do release. Release also needs this pointer, but it has no arguments. So I could call this, maybe one arg or something. That'll be long. I don't know. How about release, or no, void math. This call math. This call void math. Just takes a math, a p math, right? I can't think of a good name, so we'll leave it at that for now. If we want to call release using that, we just need to get the, we'll call it math release equals, this is the type, and we need the nth function for release. For the math object, and then release is, let's get an F11 on an ion. No. Release is the 0, 1, the tooth argument, or the tooth function. So we can say math release p math. We have to supply it, and we should see the object get deleted when we call that. I'll run up to here. So at this point we're okay. We'll just step over that, and it got deleted. Alright? No arrows required, all direct, just regular function calls. Well, there are a couple arrows up here, but it's just as easy to add another type def, another function called type def, and I just add them as you like. These ones are of that same type, add ref and release are void. So you could, if you wanted, use that when I just define. Oh, it's defined way down here. You'd have to define it up there. This is true for any. This is global truth. Put any I unknown here, and the second one is the release for it. Any COM object, not just math, right? But of course, we want to call the release function, even though the way that the function operates is probably the same for all objects. You would have to define one for each. When this, wherever this goes, it may go to a common function, for all objects. But of course, we need to pass in the object itself. But there might be some objects that release differently. I could also add more observations about all of this, of course. This is just direct function calling, right? Generally speaking, COM calls will be marshaled. There will be a marshaller, and we're not getting that marshaller in either case, whether we do it manually like this or if we use the COM method. These are still direct function calls, and I'm not sure. You have to do something, specify something. Probably in one of these flags. See, like no custom marshal. I don't know what that means. Enable code download. There's a whole bunch of things from default context. Now, that sounds like marshaled, right? Active 32-bit server, inproc handler, local server. Here it's 16-bit, obviously. Remote servers. No custom marshal. Okay, fine. How do I get these to be marshaled without? Maybe you have to write your own marshaller, unless you take the next step higher in your level of COM and get these functions to be marshaled, right? So that the calls are all in the same context and we don't have any multi-threading issues. Anyway, just a quick addendum. Thought you might be curious to see that it works. And it's all exactly. I wrote this down and it compiled the first time and ran the first time. Okay, see you.